Dear students, today we will learn about Clemmensen reduction. So in the Clemmensen reduction, normally the carbonyl group is converted into hydrocarbon, right? So that is here this carbonyl group which is present in aldehyde and ketone, it is converted into this CH2 bond, right? In the presence of zinc amalgam, so that is zinc and mercury, mixture of zinc and mercury, in the presence of concentrate HCl. So this is known as Clemmensen reduction. So in Clemmensen reactions we have this carbonyl group, right? So the carbonyl group is present in normally in aldehyde and ketone. So we can take a particular example. CH3 C double bond O at example number 1. So if it is treated with zinc amalgam, that is mixture of zinc and mercury in the presence of concentrated HCl, excuse me, then this C double bond O is converted into H2. Okay, so it will be CH3. Another example we'll take from ketone. So CH3 C double bond O CH3. I'm taking this acetone. So when this acetone is treated with zinc amalgam, so the alloy of mercury is known as amalgam. Okay, so it's a combination of zinc and mercury in this case. So concentrate HCl, then it will be converted into CH2. Remember, CH3, CH2, CH3. Okay, so this reduction, okay, we know it's removal of oxygen and addition of hydrogen. So this is known as Clemmensen reduction. Next I would like to discuss about is the Wolf-Kishner reduction. Same case. In here also aldehydes and ketones which has the carbonyl group, it is converted into CH2 group, right? In the presence of hydrazine. So we'll write the reaction CH2 C double bond O. So we have taken the aldehyde. When it is treated with hydrazine, hydrazine is basically NH2. This molecule is hydrazine. Okay, then this O will remove from here and H2 will remove from here. So water altogether will release water, H2 and O. This N will clip here. Okay, bond, make bond. So it will be CH3, CH2, C double bond N, NH2, and here is H. Alright, so when this is treated with KOH in the presence of ethylene glycol. So when this is heated with KOH in the presence of ethylene glycol, everything gets removed and here comes H. So it will be CH3, CH2, CH3. Okay? So this compounds. So in this way, this is the reduction. So we'll remove O and here comes H. Now next example, I'm taking with ketone CH3, CH2, C double bond O, CH3. If we have a ketone and when we treat it with hydrazine, NH2, then our compound becomes CH3, CH2, C double bond N, here comes NH2. Okay, so here is another CH3. Okay, just rub it. Okay, so here is a CH3, CH2, CH3. This molecule. Okay, fine. So when this is again treated with your KOH in the presence of ethylene, YLEN, ethylene GLYC glycol, okay, ethylene glycol, and heat is also required, then this will convert into H2 group. CH3, CH2, CH2, CH3. So this conversion is known as Wolf-Kishner reduction, in which your carbonyl group is converted into CH2 group, right? The next is Rosenmund reduction, in which acyl chloride is treated with palladium and barium sulfate, and hydrogen gas is passed through it. Then it will be converted into your corresponding aldehydes. For example, if we have acid chloride, or we call it acyl chloride, when it is hydrogenated, okay, above this palladium and H2 barium sulfate, BaSO4, okay, mixture of palladium and barium sulfate, then this Cl will remove and H will come here. CH3, C11O. So this is a very good way for the preparation of your aldehyde. This can be applied to your aromatic group. For example, if we have this, then when we pass hydrogen gas over the palladium and barium sulfate mixture, okay, then this H will remove, Cl will remove and H will come here. So it will form your benzaldehyde. So the reduction, the removal of electronegative group is also called reduction, right? So we'll removing the chloride from here and we'll adding H here. So this is known as Rosenmund reduction. Next reaction is a Stephan reaction, in which nitrile group is converted into aldehyde group. Okay, so we'll take one example. If we have this, and so we call it nitrile in IUPAC name. In common name we call it cyanide. Okay, alkyl cyanide. So when this nitrile group is treated with stannous chloride and hydrochloric acid, it forms imine. Okay, so remember, you have to remove one bond from here, and one H will come here and one H will come here. So R C double bond N, sorry, C H double bond N H. Okay, so this is known as imine. I-M-I-N-E, imine. When this imine is further treated hydrolysis, okay, then it forms your corresponding aldehyde group. So this is known as Stephan reaction. If I take a particular example, then it will be if we have CH3, CH2, C triple bond N. So if I have this nitrile, and when it is passed through stannous chloride and HCl, then it forms amine. Remember, you have to write CH3, CH2, CH double bond and H. Okay, so one bond is removed. Yeah, H or H right? So this is your I-M-I-N-E, imine. When this is hydrolysis, then it forms your corresponding aldehyde. For example, here is CH3, CH2, C double bond O, H. So corresponding aldehyde has been formed. So this reaction is known as Stephan reaction. There is another conversion of this nitrile to aldehyde group is also there. Okay, with the help of diisobutyl aluminum hydride, we call it diabyl. Okay, we'll write that reaction. Suppose if we have this is not the Stephen reaction, but it is one of the conversion. Okay, same as Stephen reaction. So here, if we have this CS3, and when it is treated with, we call it DiBAlH. Okay, so it is a diisobutyl aluminum hydride. Okay, we call it diisobutyl aluminum hydride. When it is treated with this one, then again imine is formed, CH3, CH double bond and H. This will form. Okay, when this is further hydrolysis, then it is CH3, CH, C double bond OH. Now corresponding aldehyde has been formed. The one of the advantage of this diol is that it doesn't affect your double bond. We have this molecule, so when we use this DiBAlH, diisobutyl aluminum hydride, then same thing, amine will form. Okay, this is amine. So CH3, CH double bond, CH, CH2, CH double bond and H. So this is your amine. Okay, when this is hydrolysis with water, so CH3, CH double bond, CH, CH2, C double bond O H. So this compound will form. So it does not affect the double bond here. So this is one of the important reactions. Note that if this double even convert your ester into your corresponding aldehyde. For example, if we have this ester 3, when it is treated with in the first step DiBAlH, diisobutyl aluminum hydride, and followed by hydrolysis, then this side CH3, C double bond OH. So aldehyde will be formed. Okay, the use of, so even the ester can be converted into aldehyde with the help of this diol followed by the hydrolysis. The next reaction is the Etard reaction, in which toluene is converted into your benzaldehyde, okay, with the help of chromyl chloride. The reaction is like this. We have a toluene CH3, TOLUENE, toluene. When this is treated with chromyl chloride, CrO2, Cl2, chromyl chloride. In the solvent will be carbon disulfide. When this is treated with this, now this is basically two molecules utilized here. So two of the H will be replaced by this molecule. So you have to remember the structure is something like this: CrOCl. Okay. Now you have to break one bond here. Okay. Then you have to attach this O with carbon, and the H will come in other side here. H. Okay. So it follows a free radical mechanism, so I am not going in the detail. So you have to write here. So two molecules of this combines with this carbon. So your structure becomes CH, then there will be this O, okay, then Cr chromium, then there are 3. OH group is there and Cl2 is there. So similarly here is O, Cr, OH, Cl2. Okay, so two molecule basically utilizes here. So when this is followed by hydrolysis, you have to remove this one, this. Okay, so when the hydrolysis takes place, then it becomes CHO group. CHO. So it forms this. So the conversion of toluene to benzaldehyde with the help of chromic chloride followed by hydrolysis is known as Etard reaction. Now remember that this is the partial oxidation. Okay, we call it is a partial oxidation reaction because in other reaction, if I treat, okay, so if we treat this CS3 group with strong oxidizing agent like alkaline KMNO4, we know that the complete oxidation takes place and it forms your carboxylic acid group. Okay, so remember, so complete oxidation, if we do the complete oxidation of toluene, it results in the formation of benzoic acid, right? But if we do the partial oxidation, like in this Etard reaction, it will come with the product benzaldehyde. Next is Gatterman-Koch reaction. In this reaction, benzene or its derivative is converted into your benzaldehyde group. Like if I take a benzene, okay, and when it is treated with carbon monoxide HCl, anhydrous AlCl3 or cuprous chloride, then will form a benzaldehyde group, right? So I'll write here CO. So the conversion of benzene or its derivative with the help of carbon monoxide HCl and anhydrous AlCl3 or CuCl cuprous chloride, then benzaldehyde is formed. So this reaction is known as Gatterman-Koch reaction. Thank you.